afternoon, everyone. Yes, and hello, everyone, and welcome to At America. Yes, thank you so much, everyone. So, welcome once again to At America, the U.S. Embassy's American Center. And first and foremost, everyone, please allow me to introduce myself. My name is Genara Jusuf, or you can call me Ara, and I will be emceeing for today's event. And for those of you new here, At America is the U.S. Embassy's American Center, in which our mission is to provide a space for people to learn about the United States through our events and also our programs. And before we begin, everyone, I would like to welcome and also greet our audiences from Institut Teknologi Bandung. Yes. Thank you so much, and everyone. And we are also joined today by our friends from Universitas Trisakti. Yes, thank you so much, everyone, for joining our event for today. And our event for today is titled Innovation in Action, U.S.-Indonesia Water Solutions for Responsible Mining. And before we begin, we will have a social media quiz for our online audiences. And the question of today is it true or false? Water use in mining is essential for several processes. If you think you know the answer to this question, you can submit it on our social media platforms. And for those of you who can answer correctly, will receive a live shot from us by the end of this event. And ladies and gentlemen, we are already joined today by our brilliant speakers and also moderator for today's discussion. But before that, we will be hearing an opening remark that will be delivered by the economic officer of the U.S. Embassy Jakarta. So ladies and gentlemen, please welcome Tina Bakten.
Thank you. Yeah. Thank you very much. Good afternoon, everyone. Selamat sore, everyone in the room, our guests, and those of us joining online. We're really glad you could join us. My name is Tina Bakten. I'm an economic officer at the U.S. Embassy in Jakarta. I've been here a little over 2 years in our Environment, Science, and Technology unit, where I and my colleagues cover disaster management issues and pollution, including water. And we are focused on supporting U.S. businesses and working toward mutual priorities that we have with Indonesia. So thank you so much for joining us. We're very excited to have an expert panel led by our visiting U.S. water expert from our National Park Service. We're very excited to be joined by a representative from a U.S. company here in Indonesia, EcoLab, and ITB's very own professor joining us, as well as a colleague from BRIN, the National Research and Innovation Agency. So as you all know, fresh water is very important to all of our safety and security and prosperity. And the focus of the US government currently is on innovating and investing in approaches to secure our water supplies. We're really looking forward to sharing US lessons learned about mining and water resource management, and also learning from Indonesia's extensive unique experiences on this topic. This event today is part of an ongoing research and academic and government dialogue, networking, and information exchange we have with the Indonesians to promote trade and economic growth and to protect our natural resources and supply chains. So we're very excited again to be with you. Thank you so much for joining us, and we look forward to a really illuminating discussion with our distinguished panelists. So thank you so much. Thanks.
All right, thank you so much to Tina Bakten for the very insightful opening remarks to begin our event for today. And ladies and gentlemen, to lead and also navigate our discussion, we are already joined by our moderator. So ladies and gentlemen, please welcome news presenter Akbar Syam.
Okay, give applause for Ara. Ara, I have special pantun for you. Anyone, please say cakep. Indonesia. There's no pantun from English, from Indonesia, Melayu. Simatupang rasa California. MC MC dipandang buat kita bahagia. Sekali lagi tepuk tangan untuk Ara, teman-teman semua. Yeah, like Ara said before, I'm Akbar Syam, I'm a news presenter, also stand-up comedian. But now I'm not both of them, I'm as your moderator. But before we're going to our panel discussion today, I'd like to check your spirit. My right side is from ITB. ITB. Guys, saya mau kalian berikan tepuk tangan yang paling meriah. Oke? 1, 2, 3, tepuk tangan yang paling meriah. Oke. From my left side, dari sisi kiri saya nggak mau kalian kalah dengan dari ITB. Trisakti kan, kampus demokrasi perjuangan. Kalian harus lebih semangat hari ini. Berikan tepuk tangan yang paling meriah. Oke, thank you. All of guys, give applause for you all guys. Well, today, anyone, it's a pleasure to welcome you to today's discussion, Innovation in Action, US Indonesian Water Solution for Responsible Mining. As the demand for critical minerals continues to grow, the challenge is no longer simply how to extract resources, but how to do so responsible within protecting the environment and ensuring the long-term sustainability by water resources. This brings us to a fundamental question at the heart of today's event. Can mining and clean water coexist? So let's join the conversation. And I'd like to invite the speakers for today. First speaker, he likes nasi goreng in Indonesia. I'd like to invite Mr. Stephen Edward Rice, Groundwater Program Lead, National Park Service, U.S. Department of the Interior. Hi, Pak Steve. Indonesia, we call you Pak. Thank you. Have a seat. And the next speaker, we'd like to invite Dr. Insinyur Muhammad Sonny Abfertiawan, Associate Professor, Environmental Engineering, ITB. Hi, Prof. Inshallah ya. Just Sonny, please have a seat. The next speaker, Professor Dr. Cynthia Heni MSc, Senior Researcher from BRIN. Prof. Cynthia, we live at America, not TVRI. Please have a seat. And the next speaker, Mr. Tommy Suryatama, Industrial Marketing Director of EcoLab Southeast Asia. He just landed from Palembang. Just coming. You eat MP-MP?
Oh,
Yes.
yes.
Yes. Okay, have a seat. Yeah. Anyone, let's begin hearing from our distinguished speakers. And the speakers will share the presentation in 10 minutes. So the first speaker, we honor to welcome Mr. Stephen Edward Rice, Groundwater Program Lead at National Park Service, U.S. Department of the Interior. With nearly 2 decades of experience in groundwater assessment and management, Steve has worked extensively on water quality, water supply, and environmental protection across the United States. Mr. Stephen, floor is yours.
Thank you. So, as was introduced, I think we're all here today to hear about the interactions of mining and water quality in Indonesia. And my role here is to provide a United States perspective and a United States history on our interactions with the mining industry and water quality. So I'd like to start by providing some information on why I am standing here on this stage before you today. I have been honored to been participated and selected to a program known as the Ambassadors Water Experts Program. This is a program that is a joint venture between the U.S. Departments of State and the U.S. Departments of Interior, where we provide short-term technical assistance on water-related issues to international counterparts. These are generally initiated by the U.S. embassies and consulates within these countries who speak with the folks that are on the ground, who's seeing the issues and so forth, and bring these to the Department of State, who can then partner with Department of Interior staff, such as myself, to leverage the extensive experience that the U.S. has in water use and water management, and in particular, water sustainability as well. The AWEP program was started in 2019, and in that time period has completed over 40 projects in over 35 countries, although this is the first time that we have done one of these deployments in Indonesia, so we're very excited about seeing where this one goes. And I am one of over 100 U.S. experts that have been deployed to these various countries to address these various topics. So this is a summary list of some of the assistance areas that this program has provided related to water and water resources. The one that it brings me out here to Indonesia related to mines and mining water quality touches on several of these areas, including groundwater management and monitoring, water quality and treatment, remote sensing, using data to inform management of water resources, water policy and regulation, the regulations that are driving the standards and the procedures and the permitting process to get mines operating and running and reclaiming sites. And then finally, looking at issues of restoration and ecosystem management. So this is a very broad agenda and topic area for me to be out here with, touching on many of the typical subject areas that this program specializes in. Looking at the specific objectives of my time out here, it's to provide a U.S. perspective in approaches on handling water quality issues, particularly related to mining, and then learn with and to discuss with Indonesian counterparts from industry, from embassies, from research institutions, and so forth, to learn about common challenges that exist between the United States and between Indonesia, areas of success, areas of challenge, particularly related to water management and monitoring and enforcement. And then discuss some of the new and emerging technologies that are coming out of both the United States and by researchers and advancements here in Indonesia. And then finally, I've got 1 week here in Jakarta, and then starting next week, we will be traveling out to different areas within the country to see some of these sites in person and speak to some of the more local communities that are dealing with these issues. And then to return to the United States, summarize findings, and provide recommendations, which we can then use to design targeted future engagements where we can really dive in and address these issues firsthand. So looking at the issue of mining and water quality, Indonesia, as you all likely know, has a great deal of mineral wealth and a great deal of ecosystem wealth as well. A number of very unique and pristine sites, including UNESCO World Heritage Sites and so forth. And the United States, in a similar fashion, also has great mineral wealth and also great natural resources. I should know I have the honor of working for the National Park Service, which is charged with protecting and preserving some of the United States' most iconic landscapes. And I do so under the frame of sustainability, water sustainability and water security, so we can develop resources safely and not end up with any unacceptable impacts as a result of those actions. We do that because impacts, particularly to water quality, impacts from the past and the present, are very long-lasting. And so as we're talking about the issues of overlap between mining and water quality, and then can those two issues coexist, there's a number of questions that we need to answer first. How do we monitor effectively? Are we asking the right questions of the data that we're collecting to be able to understand what it is that we're doing on the landscape related to mining, and is it a sustainable process? How do we leverage technology in processes? There's a lot of advanced technology coming out of both the United States, researchers in Indonesia, and other parts of the world that allow for mineral development to occur without some of the legacy impacts that have been seen by mining in the past. And then finally, how do we incorporate public input? This is an area where that we focus on in the United States, making sure that the public, particularly the communities that are in and around areas where mining is occurring, have a seat at the table, that they're aware of what's going on in the permitting process, in the monitoring process. They have a say in reclamation and what these landscapes are going to look like in the future and so forth. So From a U.S. perspective, I think that we have a lot to offer to this area. We're about to celebrate our country's 250th anniversary in a few weeks. And mineral extraction and mineral processing has been a large part of that process, from utilizing coal in the Industrial Revolution in the 1800s to the gold rush that propelled our western expansion of the country, to copper, electrifying our nation, and then finally, more recently, the issues of critical minerals and rare earths that are so important to electrical vehicles, the clean energy economy, AI, and so forth. And so the United States over these time periods has learned a lot of lessons, and we've learned some of those the hard way. But it has shaped us into a world leader in how to mine sustainably, how to monitor our resources and make sure that impacts that may be occurring are not unacceptable. And then remediating issues and problems from the past, all the while adopting new approaches as they become available to us to make the mining industry more sustainable. So when we pose the question about whether mining and water quality can coexist, I think that in the not too distant past, this would have been a very difficult question for me to answer. But I think now with the available advances in technology and the acknowledgement and the adoption of the concepts of sustainability and so forth, I do think that it's achievable, and I'm very much looking forward to speaking with my fellow panelists here and discussing this issue more. So I appreciate the time and the opportunity to speak with you today, and I'll hand it over to our next speaker. Thank you.
Well, give applause for Stephen. And the next, we'd like to invite Dr. Insinyur Muhammad Sonny Abfertiawan, Associate Professor Environmental Engineering ITB. Please.
Okay, thank you. Good afternoon, everyone. It's happy for me to be here. And I'm sorry I say that I prepared this slide not for today, but for tomorrow workshop. A lot of slide here, but I try to make it simple. And yeah, I will talk about the mine water management in Indonesia. What is the lesson learned from my research perspective, innovations, and field implementations. Sorry, this is my profile. My name is Sonny Abfertiawan. I'm working for Water and Wastewater Engineering Research Group, Faculty of Civil and Environmental Engineering, ITB. Okay, let me pass this one. Okay, I just want to look. Actually, Steve already explained about the challenge of mining industry, and honestly, I just want to say that we have different challenges with America, with US conditions. Let we start from here. I did scraping data from the internet. I asked what is really happening in Indonesia related to the environmental in mining industry. So you can see from this data that water management become the biggest problem in our country right now. As you know, maybe last year at the end, 2025, we have a disaster. And as you know, mining industry become suspect of disaster if you read some newspaper. Okay, so you can see it here, water management, the most important thing. And okay, I see. Like I said before, why we are very different with US case study, like Steve told to you, because we have a lot of rainfall. We have average reach until maybe 3,000 millimeters per year. So a lot of water coming from our natural conditions to mining sites. That's very challenging. Okay, and then so if we try to understand what really happening with our mine water management in Indonesia, I try to divide two variables. First, quality, and first quantity, and the second is quality. Quantity, we have very huge volume of mine water. In this previous presentations, Steve showed to us discharge grab. The discharge reached to, if I'm not wrong, 4.6 cubic meters per second. It's very small for us. In Indonesia, it can be reached until 40 cubic meter per second. It's very huge volume of mine water. So, because we have different hydrology characteristic in Indonesia, in a tropical country. And the second is quality. Many water quality problems because so many mining industry do not understand about the characteristic of the geology. So they cannot predict what is the characteristic of the mine water. So this has become problem because when you want to build or you want to plan the mine water treatment, you must understand the characteristic of mine water, the source and also the mine water. Okay, I will try to pass this way. So this is the type of mine water. Yeah, and if you read in some literature, they divide the mine water into 3 types of mine water. First, acid rock drainage, this one, or acid mine drainage, and the second is saline drainage, and the third is neutral mine drainage. But in 2023, I tried to propose this nomenclature, high total suspended solid drainage, due to the clay minerals. This is big problem in some mine area in Indonesia. Like you can find high total suspended solid mine drainage in the border of central Kalimantan and East Kalimantan. The concentrations maybe until thousands milligram per liter. So it's very difficult to be settled by natural gravity. So we need to intervene by using chemical process. Okay, what else? So yes, we need to understand the characteristic because coal, gold, copper, and nickel have a different characteristic. And coal, we have maybe we have nitrile, we have acid due to the presence of sulfate minerals. Gold, copper more complicated because you have more metals concentrations with high concentrations in the mine water. And nickel, nickel we have a natural pH, but the metal presence in the mine in the mine water. And this is the important thing that you need to know what is the characteristic of your mine water. Because without this one, without understanding the characteristic, you cannot design the mine water treatment. No, you cannot do that. Okay, this is the example of nickel mine water. You can see that nickel mine water actually, because the pH is neutral, it's relatively easy to be treated because we just settle the solid by using gravitation. It almost remove almost 90% of metals. And yes, in nickel we only have chromium hexavalence, become a big problem in nickel mine. So my point is laboratory characterizations is very important to treatment strategy and process optimization. Okay, let me pass this one. It's a little bit technical. Okay, this is what we already done in our research group. We trying to understand the characteristic of rock materials. Is it potential acid forming or not non-potential acid forming? And we also trying to characterize the mine water by using texture sample from the mine, nickel mines, gold mines. Okay, now this is another problem that I told to you. We have problem with the discharge, the quantity of mine water. You can see that Steve told 4.6 cubic meters per second, but in Indonesia, it can be reached until 20, 30 meter cubic per second. It's very, very huge volume of mine water. No technology can be used without control the mine water. So the important thing that when we talk about mine water is we need to control the discharge. Without control the discharge, we cannot treat the mine water. That's become problematic in Indonesia. That's why we, in our research group, we try to help many industry to control the discharge. We plan to build a detention pond or retention pond to control the water. So the idea is we want to make a stable discharge flowing into the sediment pond. So it's more easier for us to inject the chemical and it more optimal process in the sedimentations. Okay, this is the idea of detention ponds. We built a dam infrastructure and it can equalize the mine water coming from the active mines, and so we can more easier to treat the mine water. Okay, this is the example. This is a nickel mines. We try to make what we call multi-stage flow reductions. So we don't build a big dam, but we build a small dam, but multi-dam in the same river. So the idea is we want to reduce our discharge from 30 cubic meter per second into 1.5 cubic meter per second. It's more easier for us to treat, to inject the chemical. So yeah, that's the idea. And another about the distribution of flow, I got this presentation from Tiff Hilton from West Virginia Task Force last year. This is also important. So when we build a sediment pond, we are not talking also about the capacity, but also the geometry. Okay. 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 This is the example of how the impact when we consider the geometry, the discharge, and we can treat the mine water easily. Okay, I think that's all because the time is gone. Okay, it's very okay. This is okay. This is I think this is the closing and key takeaways. And first, understand the source, the characteristic of the rock and as well as the mine water. Control the pathway, characterize before you treat, design based on science, not just without any methodology. Optimize and then automate, protect the receptor. I think that's all for me. Thank you.
Well, thank you, Mr. Sonny. By the way, I like the way you wear your glasses, like this. I can do because if I do like this, I couldn't see you clearly, guys. So, thank you, Mr. Sonny, our future professor, Amin. And the next speakers, Professor Dr. Cynthia Heni, MSc, Senior Researcher from BRAIN. Give applause for Professor Cynthia.
Thank you everyone. Hello, my name is Cynthia Heni. So actually currently working at Research Center for Limnology and Water Resources, BRAIN. So what do we do actually in BRAIN? Like probably everybody knows that our main job is doing research, right? I mean, and especially in limnology, have anybody knows what is limnology? Probably one here student? No? It's technical lingkungan, right? How come? What about from ITB? What about Pak Sonny, student? Have you heard about limnology? No? So sad. Limnology, what is limnology? Knowledge about what? To learn about what? Only lakes? Okay. Yes, yes. Actually, limnology, actually, we're studying for inland waters, connection between abiotic and biotic, right, interaction means that the physical, chemical, and biology have to together, right, interact together. So it means that when we talk about clean water, we're not talking about clean water only for like we drink the water and also provide for supply clean water. We do not talk about that in BRIN. We talk about ecosystem, right? So it means like inland water, freshwater ecosystem, very important, yes, for water supply, for drinking water, right, to provide us. But it's important actually who lives in the ecosystem. So it means that when we talk about mining activity, right, can we balance mining and clean water? Hypothetically, yes. Whatever the dirty water you have in the river or in the lakes, you can drink with, how do we do it? For environmental engineers, treat, right? So you can treat. But in terms of ecosystem, how do you treat it? Like if we talk about rivers and then lakes, that bring us our responsible to protect the ecosystem. So most of research that we do, actually we care about the living system, not only clean water, but living system in terms of organism. So what I actually emphasize today in terms of mining activity, there is one gap usually. They always like in terms of environmental standards, like water quality standard, they're always talking about the chemicals, right? But actually not. I mean, we have to care about also the living things. That's why we call it baseline study. We call it bioindicators. So those the things that are very important that actually missing in terms of the water quality standard. We miss that for environmental impact assessment. Usually they always care what's the key parameters for the mining impact on the ecosystem. Pak Sonny, what's the key parameters before they said? For mining activity, like if you pollute the river, like Pak Aman mentioned, to meet the standard, what is one parameter, the key parameter for before you dump the waste or the tailing, whatever, the runoff? The key parameter is TSS, right? You know TSS can affect in the lakes, in the rivers, cover the sunlight. A lot of organism. So those are the things. And actually, environmental ministry only standard, whatever, 100 something ppm. That's actually not for the ecosystem. So that's why we have to make clear in terms of clean water and then the mining activities. You have to differentiate. We need clean water for ecosystem, or we need clean water just for our needs, I mean, for human being needs. So those things that BRIN has to emphasize actually baseline assessment. So those the things that missing from the water quality standard actually bioindicators. So we have to look at the, for example, like a baseline river or lakes that can be affected by the mining activity. You have to look at the organism, the very sensitive one. You know that in Citarum, they just found, not Citarum, Ciliwung last time, about the janitor fish, right? Whatever, these fish can live in the very dirty environment. Those, you cannot use that fish as a bioindicator. So you have to use the sensitive one that, si Paman, whatever the organism live that naturally, those are the things that you have to look at. So means that when mining, active mining, so we have to assess like early stages of environmental impact assessment, and then you have like in the middle, like during the mining activity, and then post-mining activity. Do you still find that organism in there, right? So those are the things that actually bring really concern for the ecosystem. So not just clean water. Hypothetically, yes, we can have clean water and we can have mining activity. But definitely, I have years and years experience as a researcher or as a speaker or expertise consultant for mining activities? None, actually. Most of them polluted the environment. Most of them, not just, we're talking not just suspended solid. We're talking about metals, toxic metals, like nickel. It's not just what before you mentioned. Actually, there is chromium-6 in that, what you call it, like toxic metals. Like if you kind of open cut the land, you know, so you can have like what you call it, the metals that also are leaching, right? Leak or leach from the soil mineral. Those are things you have to care. Like for example, gold mining actually not from the mining itself, actually from the processing. From like for example, like amalgamation, right? You use mercury, but in terms of nickel or coal mining or other, right, copper, you have this metal, toxic metals that are leaching from the open land. So those are things you have to care about in terms of polluting the water resources. So those are things. Probably that's it. I can you know, I can share with all. In terms of research, actually, whatever Pak Sonny done, we cover a broad range of or topics in terms of research. We have those whatever Pak Sonny has been doing. We also have the expertise. But the only thing that Pak Sonny doesn't have, those bioindicators expertise you don't have. So we have the ecotoxicology. In terms of technology, whatever you have this nature-based solution or best practice, we do have that too, yeah. But the only thing that BRIN can be proud of, that we have this research in terms of bioindicators, that probably I also right now selling what BRIN can, what BRIN can contribute to have this, what you call it, sustainable mining. Okay, thank you everyone, thank you.
Thank you, Professor Cynthia. Prof, later, if shouldn't answer your question, just ask them if you want to join BRIN, answer my question. I believe they answer your question. Thank you, Prof. Cynthia. And the last speaker, Mr. Tommy Suryatama, Industrial Marketing Director of EcoLab Southeast Asia. Please.
Thank you. Good afternoon, all. Thank you for the U.S. Embassy for inviting us for this event. My name is Tommy Suryatama from EcoLab. EcoLab is U.S. company. We operate global 100 years, more than 50 years in Indonesia. We have like about 30,000 employees, 20,000 of them are engineers, so a lot of ITB, chemical engineer in our company. Not so many in Trisakti, maybe you can apply later on. We are providing the water and hygiene solution for the industry and institutional to protect people, right? And to protect what is vital. One of them is water, yeah. So I would like to share today different perspective. I'm not really environmental person like the ITB and the BRIN. I would like to share from this perspective how we can utilize the water properly and efficiently so it can give the profit to the company so they can protect our environmental better. If you don't have money, how you can protect the environmental, right? And the water is the hidden lever in mineral processing because there is no price, right? It's very cheap in Indonesia. You have a lot of rain. They just use it and I don't care, right? Send it to the environment. But if we can make the water, giving them more money to the company, so they will protect the water because it give them the money, okay? So from that, there's I think all of you know this water energy nexus, right? Water need energy to transport, to move it, but energy need water. So if we can utilize water better, we will reduce the energy consumption also. And it's mean reduce the cost. It's mean the carbonization. It's mean the greener environment, right? So, okay. Let's see from mining, yeah. Mining and smelter is the most intensity industry. From the energy point of view, come on, you crush the ore, right? Big, heavy equipment. Then you separate it. Then you put in a furnace. You put a lot of fuel, a lot of electric to smelt it. Then you refine it, right? So you use a lot of energy. And in every step of the mining and smelter, you use water. Okay? When you extract the ore, when you separate from the metal that you want and the things that you don't want, you call it whatever, dissolving, flotation, solid liquid separation. You use water in the mineral processing. And to refine it, you need a lot of power, right? You need a lot of electric. And you use water for the power generation. And after that, you send it out to the environment. And it goes with the water also. So the water is every step in the mineral processing and in the smelter. Okay? So if you can manage water better, you will get more yield, higher yield. You can reduce your energy, and at the same time, you can reduce your emission automatically. That's water energy nexus. Okay? So people think if I use a lot of water, I will be more efficient in energy. I cool down my system better. No. I dissolve my waste better. I dilute my waste better. I use more water. It's not correct. If you can recover more mineral back to the process, you get better product, less pollution. If your water chemistry is correct, okay? If your water treatment is correct. Okay, so sorry. You can see from the utilities, refinery, tailing, process chemistry, that's all about the water. So water in energy nexus, yeah. 30% of energy is transferred by water. In manufacturing, 70% of energy transferred by water. Whether heat release by the steam, whether it's power, or cooling, heat absorb, is using water. So can you imagine if you can saving 1% of that and 1% of energy? Then how many CO2 that you can save, right? So controlling water, you controlling energy, and you reduce your emission automatically. And most of the time, the project that use the water more efficient pay by themselves. Okay? Its return on investment is so high, so you can pay the project by themselves. You don't need to invest and take the money from the bank, because the project is paid by themselves because saving the energy. So where is in the mining where the water chemistry is important? First, like Pak Sonny present, is a flocculant, right? Coagulant. How we can remove the solid from the water, right? That's a chemicals. If we can remove better the mineral, so we can get higher concentration of mineral for the next process. And our water is cleaner, yeah? Filter wash it, we reduce the moisture from the product, so the next process using less energy. Flotation chemistry, right? In the copper and gold is really important. Scale inhibitor, so you can use water more concentrate. Recycle, keeping reuse, and you put a chemical to prevent this dirty water create problem to the process. So less water sent to the river, sent to the sea, sent to the environment. And the cooling water program. All the smelter are using big cooling water. That's actually the biggest water consumption in the smelter is a cooling water. If you can use more efficient, then you optimize the energy, you optimize the cost, you lower the emission. Okay? So different perspective, because I'm a sales guy, okay? I cannot sell a solution based on this will really help the environment only. This will help the environment and giving you profit. Then they will buy my solution. If I only, okay, you got if you save the environment, then you'll be happy, everybody will be happy. I cannot sell. I only can sell if my solution is work, save the environment, but they get more money, okay? Very good. And Sonny also already shared, Stephen already shared, smart water first is about chemistry, the right design of the program, like Sonny, right? What chemistry that you have from the rock, from the gil and the water. What is the reaction, and what chemistry do you need to use it more efficiently? But the system is dynamic. Mining is dynamic because the rainwater can go up like 10 times or 20 times in the rainy season compared to dry season. Then we need to measure it properly. We need to detect it. We need to have automation. If the flow is increased, what we can do with our chemical? What is the impact on the pH? And In this era, we have all the online sensor. We have all the internet. We have all the AI data, inside data, cloud analysis. Then we can put all this instrument, this automation, to find the solution for us to automate. And you only can have it if this automation, if digital and all the things, giving the benefit to the mining company, giving the profit to the smelter company. Then you can sell the technology. And we sell 30,000 of automation the whole world. In Indonesia, we sell 2,500 of the water automation in Indonesia only. They will not buy the automation if we will not give saving and benefit to them. So our job is how we can save the environment, providing the solution, technology, but we can help the mining getting more profit. Yeah, so everybody happy. People happy, company happy, shareholder happy, community happy, environment happy. That's the really ideal, okay? It's a sales talking, don't take it seriously. Okay, thank you, thank you.
Everyone must be happy, ya, Pak Tommy. Yeah. Okay, thank you to all the speakers. Please give applause for our speakers today, everyone. And yeah, we have heard valuable perspective from international expertise, academic research, brain, and industry innovation. With those insights in mind, let's move into our panel discussion and explore how these ideas can help shape a more sustainable future for mining and water management. I will go first to Mr. Steve. Pak Steve, based on your experience managing groundwater resources across the United States, what are the most critical principles for protecting water quality in mining regions?
An excellent question. So I'd like to say, if we go back to my introductory remarks, I think that I was remarking back to times when regulation and technology and best practices were not where they are today. And we've seen the impacts of that in the United States in particular. We have over 500,000 abandoned mine sites that are located within the country from a time period before we we knew better. Before we had the advances in research and technology and best practices and the concepts of sustainability to promote development, but also making sure that communities and ecosystems and so forth were not bearing an undue and unacceptable impact and so forth. And so where I was aiming with that towards the end was if I were to answer that question about what were the major threats or the major issues with groundwater quality and water quality in general related to mining, we've come a very long way from where we were prior to our current state of knowledge on this issue. But it doesn't mean that we're there. And I think some of the actions that Sonny was bringing about engineering approaches that can be employed to reduce the amounts of contaminants that might leave a mine site and enter the environment, or some of the ecological approaches to passive treatment and wetlands and so forth that can take contaminated mine water from a site and out the other end of that process be providing fresh water to the environment, or even advancing some of the technologies that Tommy was talking about leveraging new advanced technologies that keep water out of mine tailings, which create acid mine drainage, which enter the environment and so forth. And so our challenge is always related to water's interaction with geology, water coming from the sky and overtopping the engineered facilities that we have at mine sites and so forth. And so it always comes down to the core being how water interacts with our environment and our mine sites. And so to address the issues, the main issues, I'm not going to limit it to groundwater because it's both groundwater and surface water, is making sure that we continue to support the work that researchers such as Brin and ITB and other institutions within Indonesia have the ability to come to mine operators and come to regulators and so forth and saying, the processes that we have in place are not adequately meeting the needs of our communities, meeting the needs of our environments. We're still seeing unacceptable levels of contamination in our waterways and in our drinking water, in our lakes, and so forth. And so please, support our research so we can come up with the solutions and we can come up with the new techniques that can be employed at these sites so we can do a better job of keeping these things from occurring in the first place. And I don't know if actually I've addressed the question adequately that you presented me in the first place. I may have made a very circular conversation about this, but I think it's a very good reflection on the extent of experience that we have here, standing on this or sitting on this stage right now as a microcosm or a small example of the knowledge and the experience that is available out in the environment to rather than just accept that mining pollutes the environment, that there are there's some people and there's some techniques and there's some research that we can lean on to incrementally get better and better in our ways of handling this towards that ideal and towards that future where mining and water can coexist without these unacceptable impacts. So.
Well, thank you, Steve. Anyone, after this, we'll open a Q&A session. So if you, like Prof said, if you give a question, you will get a plus point. Yeah, Prof. So just prepare your question after this. I will give you a session to give a question to our speakers today. And then I'll move to Mr. Sonny. Mr. Sonny, from a research perspective, what are the most significant impact that mining activities can have on water resource if not managed properly?
In the context of mine closure, we will have a big problem, or even if I can say that it become a big disaster for our community, of course, not only for environmental. So that's the most important thing. You need to understand the characteristic of our environmental before it's mined, and during the mine phase, and you must think about what will be. What is your plan to close the mine? So if you cannot manage the environmental, especially mine water, can you imagine we will have a million, even billion cubic meter in our void, in our pit lake. If it has bad quality, so like what Prof. Cynthia told, we have a big problem with our mine pit lake in closer phase. So yes, I think it's very important to mining industry collaborate with government, of course, with academia and also in, research institute to develop, to manage the environmental better, and then we hope that in the mine closure it can how to tell, we can save the environmental in the closure phase. I think that's it.
Yeah, it's really important to mining industry collaborate with government.
Yes, yeah, that's the problem in Indonesia. I think.
Indonesia.
Yeah, there is no collaboration between.
There is no.
With a mining industry, with academia in university or research institute. We need more collaborations among the stakeholders.
We need collaboration. I will ask it to Prof. From BRIN, yeah, because BRIN is, we are government. So how about the collaboration? Why it's become a big problem in Indonesia, Prof?
You should ask the industries, not BRIN,
So in government POV, government as a BRIN POV.
Not all mining industry cannot collaborate with other party. I believe that Pak Budi already collaborate with university, with government. but we have a lot of mining industry.
We love
Yeah,
a
yeah,
lot of
yeah.
meeting industry.
Yeah, we
See,
used
Prof.
to actually, of course, in terms of probably communicating or in terms of networking, you know, for us, Brin actually, we still actually have that collaboration, but not really. I think so for limnology, not really in terms of industry, but mining we did have with INCO. It depends on the mining company. Like Vale now, it's hard, you know. But and then Inco at that time, years and years, we had collaboration, research collaboration, you know, because we have to protect these ancient lakes in Lake Matano, and 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 also I would like to mention that it's hard to get the collaboration, but when it occurs or it happens, that really worse, like a pollution, environmental pollution, and then people already like protest, and then they will ask us to get the, you know, to get the perspective or to get the research done. That's what happened actually. So it is important, especially because of probably why they don't want to collaborate, because it's expensive. And for us, I mean, usually it's not just doing research. As I mentioned before, that we need, in terms of mining, we need the long monitoring. So it's not just at the beginning, like environmental impact assessment, but after the post mining, we need to have that monitoring, because why? The see example in Bangka Island, Bangka Belitung, you know, those are a lot of pit lakes that actually the people use the water for their daily water supply or clean water. But actually, it's not acceptable because still the pH low, and then metals concentration. And why we need the information or the data? For example, like they usually fishing, like they just put the fish in the pit lake, and then they fish, or they put like a floating catch fishery, right? But actually the fish accumulated the metals. So we have to have those information to them, you know. Otherwise we kill them. See, a lot of people in Bangka, they have this problem with the stunting. So I think one of the problem. So I remember when during the Indonesian Institute of Sciences, we spent years and years to do research there in Bangka. So that's why important. So I guess this talk show kind of give knowledge also for the young generation to continue to pass on with our with our knowledge, with our probably give empowerment to the people, you know, to have a better health or better life.
Yeah, to better life.
Yeah, to
I,
the
I
future.
quote, thank you, Prof. I quote what Pak Tommy said last time, everyone must be happy. Yeah, in sales. But Pak Tommy, technology is often seen as a key part of the solution.
Yeah.
What innovation are currently making the biggest difference in water management within the mining sector?
I think the chemistry, because the unique thing of oil, mining, geothermal, every field is different. Every ore is different. Every rock is different. So once you open one mine field, and there's a challenge to find the best chemistry that can work to refine, to separate. So those still the polymer things, all the flocculant, the polymer, the rheology, all the RRX is still moving. But I think digital automation, digital is the most important right now here, because it is dynamic. You can see the flow is whatever the clarifier, whatever the dam that you have, flocculant, the very best flocculant cannot work if the flow is increased 20 times, right? So if we have very good sensor, right? If we have very good sensor and detect and tell us at that time, and also the trend, the statistic, then we can predict that it will happen next 6 months. That's 20 times of flow increase. So we can have a solution on that. Okay, we can develop a solution on that. Other thing that I would like to comment, I think doing the right way, using the good technology, it should be giving profit rather than just a cost, right? The problem is we not started properly. When they open the mine, they don't talk with this gentleman, this lady, have good knowledge. They just open it, and when the problem is already there, right? The whole portfolio, the whole financial calculation is not there to solve the problem. But when you talk and design properly, it should give good profit to implement all those dam, all those chemical, all those automation is already in the portfolio and giving the good profit to the investor. But if you don't design properly, then you just invest, open the dam, then you got a problem. Where's you got money to implement the technology? The technology is there, but the financial is not there, right? Because it's already, I get 40% and I promised the shareholder 40%. Then I said, because Pak Sonny recommend we'll drop to 20%. Then there's no investor want to do that, right? But since the beginning, we implement the right solution, the right technology, the right way, then the profit is already clear, everything is good. That's short, I think there's no, it's never wrong to do it the right way. It should not be, we say that we pollute the environmental, we kill the earth, we kill the fish, will be cheapest way. I don't believe it. Somehow, some way, it will give a very expensive cost to the company, whether it's closing, whether it's penalty, whatever, right? But because we don't think in the beginning properly, we don't talk to the right people, we don't collaborate. Like Pak Sonny said, it's too late. When it's too late, there's nobody want to pay. When even the technology is there, right? Because they cannot pay. Yeah, thank you.
Can I add?
Oh yeah.
Yeah. So it's ironic actually in Indonesia. They always mention that we like kind of a backward 100 years from United States, for example. But the technology is there.
Yep.
I got my PhD from 2000. It's already there. I went back to Indonesia. I wanted to implement, but there is no money and a lot of whatever policy and things like that. So it means that it's so funny that preventive action, that's what we have to do. Not after the after the destruction, the degraded environment, and then suddenly, oh, do this. You can't. Recovery takes a long time. So that's what happened.
So Steve, is there a best practice in US? I mean that we can applicable to Indonesia?
Yeah, I think my response here might touch on that, but there was a couple terms that I kept hearing over and over again that I wanted to bring in. I mean, the terms collaboration and the terms reactive versus proactive, and I think that that's one of the areas where the United States has seen a lot of success. We don't have a magic machine that Indonesia doesn't have, or this special chemical that we can put on our mine waste that Indonesia does not have, access to, or something. Where we're finding a lot of success is that we are successful in collaboration. We have collaborative institutions like the Mine Drainage Technology Institute, where there's a marriage between federal government funding and industry support and access to mine sites and academia and so forth, that they're working together and developing approaches to prevent acid mine drainage from occurring from some of these sites, and if it does occur, how to best treat it. And so that collaborative effort in the United States is taking a great leap forward in the recent decades, and I think that that's what positions ourselves to some of the successes that we've had related to this issue of mining and water quality. And the other one is this issue of being proactive or reactive. If you're not being called upon to lean on the expertise of some of the folks that we have here on this panel until something bad has happened, that's another area where the United States has had a lot of experience. We had 250 years of mining, that to lean on, many of which have resulted in some pretty unacceptable results. And so we have been reacting to the results of these past poor practices for many, many years, and have found that reacting after the fact is not the way to go, and the best approach is to be more proactive, learning what the site chemistry and the potential for acid mine generation is on a mine before it even breaks ground, determining what the potential for resilience to extreme precipitation events are going to be before a tailings impoundment is built, and so forth. And so there's no magic button or something that we possess in America that isn't available to anybody else in the world, except that I think that because of the history that we have in dealing with the past, the legacy effects of past mining in the United States, that we're better positioned in the realms of thinking proactively and taking some of these more collaborative approaches to it. So,
Well, Pak Steph, Mr. Sonny, before we are going to a Q&A session for today, because our audience mostly are from university, Mr. Sonny, how can universities and research institute contribute more effectively to helping industry and policymakers address these challenges?
Yeah, uh, I hope, or maybe I hope someday, someday there is, correct me if I'm wrong, Professor Cynthia, someday Indonesia have like mine water research and innovations consortium that's become how to talk, become or can facilitate research. We can conduct research together. We can take a lesson learned from maybe from the U.S. side or even other country. I believe that the problem is that, like I talked to you, it's very difficult to collaborate in Indonesia, to collaborate with, let's say, yeah, I just met Professor Cynthia just yesterday, today. I said to Professor Cynthia, why we not try to collaborate, conduct some research about mine water? Because in my side, I just talked about the characterizations. I just talked about the how to control the mine water, how to treat the mine water, but I do not know about the limnology. That's not my expertise. So if we can combine this expertise, I think we can contribute to the mining industry, even become better. That's the idea. So yeah, I hope someday we can give more than what we already done. Today, we have already done many things about research. We already built a technology, how we can inject the chemical automatically by using AI. We already done in ITB. But yeah, it's just prototype. We don't support from the mining industry. So yeah, again, collaboration is the most important thing to solve mine water issue.
Yeah, collaboration is the most important thing. Yeah. Okay, ladies and gentlemen, we are going to Q&A session. Anyone who want to give a question? Ooh, Prof, a lot of Prof. If I said give a plus point, they raise their hand. Okay. Yeah, good chance. Good chance. To
ask to the professor.
yeah, yeah.
The question to Pak Sonny.
Okay, first, so let me introduce myself. My name is Ignatius Fernando from Program 22 of Environmental Engineering from ITB. So maybe my question is directed to Sir Stephen and Sir Sonny. So it is also widely known that Indonesia is a country that is widely driven by natural resources such as mining and agriculture-driven programs. So you know those processes creates a lot of problem in a certain uncertain period of time that could prove to be now or even a decade or two in the future. So as a specialist, especially in the environmental section in the US, you have said there's no magic machine or there's no special policy framework that is already included in Indonesia too that could help in aiding that process. So Indonesia itself, you know itself, is very bad at collaboration, especially with the government. So is there any tips to Indonesia that you have as a US person in helping, aiding, or supporting the problem that is Indonesia, especially in the groundwater problems? So basically the question is, what are some collaborative tips or policy frameworks that could be applied to us as an institution and as a government country? Thank you.
Well, thank you. Directly to answer, Mr. Stephen. Yeah, Steve.
I'm going to give you a very non-technical answer, and I think that that's a top-down approach. I think that the incorporating the input from the public and the community, and really drives some of the collaborative efforts and the collaborative successes and so forth. But it needs to come from the top many times. There needs to be an acknowledgement and a embrace of wanting input from different areas of society, from industry, from research, from public, from the communities around, using mines as an example. Other than just saying, we have decided that here are the regulations and here are the best practices, and go forth and meet those standards. They are very site specific, and without that local knowledge, you're going to probably get it wrong or not do it correctly. And if without the support of researchers to back up what the regulations are saying needs to be done, and without the support from the communities feeling like their best interests are kept in mind, there isn't going to be a lot of faith that the regulations and so forth that are coming down from the higher levels of government are in their best interests. And so when we talk about collaboration and support from the communities and so forth, it has to be an acknowledgement that there is a value to that input from those folks. So everybody's working together, everybody's opinions are being taken and valued and incorporated into decision making and so forth. It goes back to what we're considering, what is acceptable and what is not. An impact that might be an acceptable impact to somebody that's in the top levels of government that is not looking at the impacts to a particular community or a particular lake ecosystem or something like that, is going to be a lot different than the folks who are living in that environment, who are experts in that area and know that resource very well. So I think without embracing that concept from a very high level, you're not going to get a lot of traction in sort of fostering that collaborative environment that we think is really what's necessary to make long-term positive outcomes in this area.
Well, anyone, speakers, want to? It's already explained by Steve. Everything. Okay, thank you. Thank you for the question. My left side? Oh yeah, please.
Hello, my name is Joanna, and thank you for the opportunity. I would like to ask you questions. Like, as we know, the most serious water harm that could occur often occur like in the closure. So, based on your expertise, to what extent does a private sector or a company should do in regarding the mining section, like to be called as responsible properly? Thank you.
Well, thank you, Joanna. You want to answer the question? Sonny?
I was going to say somebody with more local mining experience might be in a better, particularly for sites here in Indonesia. So.
You can answer, Prof?
Maybe in my perspective, we need to know that we already have very complete regulations to make sure that that will not happen. And we also have reclamations and mine closure bond. So if the mining industry cannot manage the environmental well, so the government can use the money to restore the environmental. That's the point of view, my point of view. So yes, of course, that is the responsibility of the mining industry. But if they can or they do not manage the environmental well, so in the side of governments, they can use this money from mining industry to restore the environment. Maybe that is from me.
Yeah, Prof, you want the answer?
No, I don't think it's my expertise to answer that. Yeah.
Joanna, is it okay?
It's more like about.
I don't know.
I think about regulation.
Yeah.
Things,
Yeah.
More about regulation policy. Yeah.
Okay, give a mic first.
I mean, to be categorized as responsible. I mean, we're talking about water solution for responsible mining. to be categorized as responsible in mining? Like, what should a company do or probably accomplish to be categorized as responsible? As we know that mining is quite, some kind of, I could categorize as dangerous probably for the environment. So to what extent does this company must do to be properly categorized as responsible? Thank you.
Okay, to categorize this one.
Yeah, it's true.
Yeah.
I mean, actually,
So
they're
the
supposed to
proper-
be. I mean, they have to sorry, they have
Yeah.
to comply with the regulation from the environmental ministry. So they actually have this regularly inspection. If they found that they pollute the environment or they do something, destroy the environment in the mining area, so they can categorize those responsible for
From-
if they pollute the for example the rivers or they what's it like a land clearance and something like that. Yeah, I think related to regulation and inspection. Yeah.
Yeah,
Related
I
to
agree with
regulation.
Professor
Can I add a
Cynthia.
little bit
Well,
on that?
Sonny first, yeah.
We have from Ministry of Energy and Natural Resources, we have regulations on best mining practices, number 1827, if I'm not wrong. And from Ministry of Environmental, we have a lot of regulation to manage the environment. We have a lot of the threshold, water quality threshold, land degradations threshold. We also have these regulations, new regulations, I think.
Pak Tommy, you want to add the answer?
Yeah, beside the regulation, of course, we need to comply, right? But there is the best in class in the world. How many water you use to produce this product, right? Say like in paper. We cannot export paper to the Europe if the water consumption per ton of paper is far away from the best in class. That's what we call responsible. How many energy that you use to produce 1 ton of nickel? How many water you produce to 1 ton of nickel? How many CO2 emission that you produce to produce 1 ton of nickel? You should be best in class to become responsible. Of course, that should not be as a stop because it's getting better every day because technology is getting better. So even you meet the regulation, but you are far away from the best in class in the world. I cannot say that you are responsible. Just because regulation is weak, but you are not the best. Okay? You should be the best to become responsible.
We're not the best, but we are the first.
Well,
ESG right now, right?
Steve, you want to add the answer?
Yeah, I was just going to add that term responsible is kind of interesting because a mining company is responsible to meet the obligations of their mining permit and make sure that they are responsible that their outflows are not exceeding a water quality standard. But are they being responsible? Is their operation responsible? Are they feeling a responsibility to do better than their minimum qualifications? Are they going out of their way to adopting new technologies? As Tommy said, we're okay, we're meeting our standards, but can we be better? Can we be the best in this area? And so that feeling of responsibility, that we have a responsibility to the environment to be better than where we are today, tomorrow. And so I think that there's, depending on how you want to define responsible, are you responsible to meet your permit obligations, or do you have a responsibility to do the best that you can to ensure that your operation is as environmentally responsible as possible?
Well, thank you. Joanna, is it okay? I quote what Prof. Cynthia said, we are not the best, but we are the first. Thank you, Prof. Anyone? Oh. Yeah, please. Yeah. Yeah.
Yes. Okay, thank you for the opportunity. My name is Andra, and I want to ask to Mr. Tommy and the other speakers I'm a bit curious about the smart water system in EcoLab. Could you elaborate the AI system, and is it only the detector system, or it controls also the quality parameters of the water, and so it can give profit to the company? And is there any obstacles or drawbacks of the system during its operation? And I have a questions for the other speakers. That do you think that there is more efficient solution to the technology due to those drawbacks?
Well, thank you. We'll go to Tommy first.
Yeah. First is beyond the automation, right? But the first, how you can have the AI on these digital things? You need to have a use of data, right? To have a lot of data, you need to have handphone online. Then is the online measurement should be there, right? Then you have a lot of data. Then you can use statistic, and you can have AI on that. And the first thing that you can have is what is the optimum condition that you can set. Say like heat transfer in a condenser, right? What is the water chemistry that's very good to give the lowest fuel consumption for your turbine surface condenser? Then from all the data that you have, all the operating condition water chemistry you can set on that pH, on that calcium hardness, on that phosphate, you will get not any falling, no heat transfer restriction, you get the highest efficiency. That's the first, right? If you have a lot of data, you can do anything with all the calculation, prediction, and those things. The second is about prediction. To predict what happened in the next 6 months, what happened in the next 1 year. If you keep operating like this, your furnace will be leaking, and your plant will be shut down, right? If you if you have those of data and you have that kind of knowledge, you can sell your solution because it's the money for the company. I guarantee you 99%, if you operate like that, next year you will get shut down because you got leak on that exchanger, you got leak on that furnace. That's $20 million US. Can you buy my solution in 100,000 to tell you about that, right? But somehow, someway, the water is not in that level yet. EcoLab in condenser, in compressor cooler, we have enough data. But for the mining, the data is not big enough to have that kind of what called artificial intelligence to predict, to tell you what's going on. Because every mining is unique. It's not like power plant, boiler is the same everywhere. You can easily put those equations. But the mining, every site is unique. And we don't need enough data population to predict, to give very good recommendation on that. But the automation on land sensor monitoring is getting cheaper now. I love to see what Pak Sonny has in ITB later on, if I visit Bandung. So we can collaborate to work together to see what kind of automation. But automation is the first level. After that, you get the data, put in database, and then you can develop AI, then you can predict, and you can estimate, you can calculate the saving, blah, blah, blah. Then you can sell this technology. And giving the money to the company, giving the money to the shareholder, using less water, minimize the pollution to the community, everybody happy, okay?
Everybody happy. That's the main point. Everybody must be happy.
Yeah.
Tommy, thank you.
Yeah.
Bu Prof?
I just want to add, actually, it's not my expertise, but actually in BRIN, we have research in terms of smart system. Like we have also developed in terms of AI research, actually in Bandung, probably Pak Sani, a lot of researchers working with AI. I know right now, one of the BRIN researcher pursued a PhD, what's a PhD for a program for in ITB actually, developed this AI to identify the polymer of the plastic waste, so we can like sort. Like we can sort the plastic waste from the river. So yeah, actually, yeah, I mean, it's still actually still developing in terms of this type of research. They develop a lot of things, I think, for agriculture, like for watering, for agriculture land, so something like that. So actually in Bandung. So if you are, so you're from ITB. So I can give the contact person, I guess.
You'll give the
And
contact
also
person.
the smart system for like monitoring the Citarum River. those things they also develop right now. Yeah, yeah. Yeah, those actually in limnology. So I can also forward to the expert in limnology. Yeah.
Steve, you want to answer?
I was just going to add, I think the second part of the question that was asked had something to do with whether we thought that, our abilities to address this are getting better in time. And I was just going to say, unless everybody at ITB and Bryn and EcoLab had the day off, we're farther along than we were yesterday. It's constantly evolving, and, as long as there an interest from private sector and interest from the research world to continue to advance some of these technologies and processes and things like that. We're just going to continue to get better. The important part is taking those advances and having them roll into regulation, have science driving the policy, and so forth. And so it's the capacity is constantly increasing. It's just at the rate of how it's being absorbed by ministries and private sector and so forth that's going to really drive how quickly we can increase this capacity.
Well, thank you. One last question. Anyone? Yeah. Yes.
Thank you. I would like to introduce myself first. My name is Mariam Dombuya. I'm a junior year student now at Environmental Engineering Trisakti University. So first of all, I would like to ask my question to Mr. Steven first. It's simple actually, but I'm curious. What do you think? Do you have a specific target or like any output that you hope you achieve out of your project? And do you think that there will be some sort of opportunities exist for local Indonesian businesses and suppliers maybe after the designated project is done? And then my second question goes to Mr. Tommy. Actually, I highlighted the front page of your presentation before, EcoLab. It's some sort of everything inside. Not only about water, but you highlighted about climate as well. Do you think climate change plays a role in affecting mining water strategies in Indonesia? Thank you.
Well, thank you.
It sounds like he got the easy question. I got the difficult one.
Yeah. Steve, please.
Yeah, regarding the question you had about what I'm hoping to get out of my engagement through the AWEP program here is going to be short-term, medium-term, and long-term. I mean, in the 2 weeks that I'm here in the country, I'm just really not only spending time, speaking to other people, but I really want to spend about half of my time here listening to people here in Indonesia to get this perspective from a ground level and so forth, that we can roll into what is the next phase in the short term of coming back and absorbing all the information that I received in my time out here and coming up with some targeted areas where we think that some assistance from the United States can be of most value to people here in Indonesia. And then on the long term, it's the issue that we keep talking about up here on the stage is collaboration. I think what I would consider a successful outcome to this engagement here is a long-term collaborative effort between maybe not myself, but me being able to make that bridge to researchers at the Environmental Protection Agency who are doing similar work to the folks here on stage or other institutions, or mating some of the new advanced technologies that are coming out of companies in the United States like EcoLab and so forth to folks out here, so we can keep this conversation going and keep that technology improving constantly, and just doing a better job for what we can for Indonesia and the United States in both directions. So that would be a wonderful outcome, and I'm hoping that comes to fruition. So,
well, thank you, Steve. Pak Tommy?
Yeah, I'm not expert at all in climate change, right? But whether this climate is impact the mining production, of course, right? Any variability, any fluctuation, any deviation in the industry will giving big impact. And if the rain today is 20 times compared to yesterday because of the climate change or because whatever, that will give big impact to industry, right? So how big is the tailing dam that you want to have, right? 20 times, how come you handle that? That's why Sonny tried to develop small one to reduce. But if you talk to the BMKG, they should have expert to say, hey, in this area, the next 10 years, the rainy season will like this. Then the environmental engineer of this and that mining company will develop the tailing system that can work on the next 10 years with all the rain rate fluctuation. But probably they don't talk each other. They don't ask, hey, next year, the raining rate is the same. They don't ask. They just develop maybe the dam for this year based on the yesterday or 10 years ago data. Then the next 3 years, the dam is gone and the community is gone because the rain is 10 times than the capacity of the dam that they built today, right? So, of course, it's impact. But this is the world that we're living, right? Then we are engineer, okay? When I join engineer, they want to say, engineer is solving the problem. We create the problem, of course, right? But we are the one that could solve it. So it's challenge for us, talk each other, collaborate, and solve all the problem. Thank you.
Collaborate and solve all the problem.
Good for the calculation, but not for.
Pak Tommy, the main point is
Everybody should happy.
Everybody should happy. Well, anyone, we are so sorry. Due to limited time, it was last question. Thank you very much for participating. Yeah. And thank you very much for all the speakers. Mr. Stephen Edward Rice, Groundwater Program Lead, National Park Service US, Department of the Interior. Thank you. And Dr. Insinyur Muhammad Sonny Abfertiawan, Associate Professor Environmental Engineering ITB. Thank you, Pak Sonny. And Professor Dr. Cynthia Heni, MSc, Senior Researcher from BRIN. Thank you from Cynthia. And also Mr. Tommy Suryatama, Industrial Marketing Director of EcoLab Southeast Asia. Thank you. Always be happy, Pak Tommy. Thank you, anyone. I hope our discussion today will give more impact for Indonesia and also for US. Thank you for coming, and I'm giving back to Ara.
Okay, thank you so much, Kak Akbar, for moderating discussion. Can we have another round of applause, everyone? Yes. Once again, thank you so much to our speakers and also our moderator for the very wonderful discussion. And also thank you so much, everyone, for attending our discussion for today. And we do hope that everyone here gain a lot of insights and also knowledge from today's discussion. And everyone, earlier in this event, we had a social media quiz for our online viewers. And the question was, is it true or false? Water use in mining is essential for several processes. And the correct answer to that is true. Water plays a vital role serving multiple functions throughout the extraction and processing stages. And shout out and congratulations to @RaskiDub from Instagram for answering the question correctly. And yes, thank you so much once again, everyone, for attending our event today. If you're interested in attending more events and also programs here in America, don't forget to follow us on our social media platforms at AT America on Instagram, X, Facebook, and also our YouTube channel. And also follow us on our website at www.atamerica.or.id. Once again, thank you so much, everyone, for joining our event today. My name is Ara, and see you at the next America event. Thank you, everyone.